In the last video, we have already solved the azimuth part for our angular equation. Now we will be solving the polar part again for the angular equation. So we want a solution for capital omega. Sorry, this is capital theta. Just remembered. Okay, so from our azimuth part solution, we have set that B equals m squared, or the square of the magnetic quantum number. So our polar part of the angular equation will be written now as, let me write the step. So our polar part will be now written as sine theta over capital theta d theta sine theta d capital theta d theta plus a sine squared theta minus b, but since b is now equal to m squared, we have minus m squared equals 0. Okay, so we rearrange this equation so that we will group the capital thetas. So rearranging, we would have 1 over sine theta d theta of sine theta d capital theta d small theta plus our separation constant a minus m squared over sine squared theta times capital theta equals 0. Okay, now for reasons that we will be seeing later, we express the wave function as depending on cosine of theta depending on cosine of theta than on theta. So what we mean by that is we will substitute p of cosine theta by we will substitute this capital theta of theta by p of cosine theta, and x will be cosine theta will be x. So by doing that, our derivative with respect to theta can be written as dx d theta d dx, and this can be written as minus sine theta d dx. Okay, so our differential equation on this form can now be written as 1 over sine theta minus sine theta sine theta minus sine theta d capital P dx plus a minus m squared over sine squared theta times p equals 0. So notice that we have transitioned from this kind of operation to this form. So this term became this term. So simplifying further, we would have sine squared of theta d p dx plus a minus m squared sine squared of theta times p equals 0. Okay, now we use the identity sine squared theta plus cosine squared theta equals 1, and we know that we have set x to be equal to cosine of theta. So we would have what do we have here? Sine squared theta plus x equals 1. So sine squared theta will be 1 minus x squared. And for this term. So now our equation will be 1 minus x squared plus a minus m squared over 1 minus x squared times p equals 0. So now we apply the product rule to the first term. So this times this, we would have 1 minus x squared, second derivative of p with respect to x, minus 2x dp dx plus a minus m squared over 1 minus x squared times p equals 0. And now this is a differential equation with a known solution. So this differential equation can be solved by Legendre polynomials. P.